Good morning all of you. Today we will study about the motion in combined electric and magnetic field. You already know about the electric and magnetic field. So let us see that if a charged particle is moving in electric and magnetic field, then what will happen. But here is the one condition we will take, and the condition is that the charged particle is perpendicular to the electric field and magnetic field, and electric and magnetic field are also perpendicular to each other. So let us take a coordinate axis. Let us suppose that this is your x, here is your y, then according to right hand coordinate system, this will be your z axis. And you know that along x axis the unit vector is I cap, along y axis the unit vector is j cap, and along z axis the unit vector is k cap. And let us suppose that at the origin the charged particle is plus q moving along x axis with the velocity v, and we can write v equals to vector v equals to v I cap. Let us suppose that the electric field is along y axis, that is E, and this E could be written as E j cap. In the same way, magnetic field could be given along the z axis, and the magnetic field V equals to V k cap. So we have seen that we have kept the velocity vector, electric field vector as well as the magnetic field vector along the three mutually perpendicular axes. Now when the charged particle, this plus q, is moving along x axis, electric field is along y axis, so it will experience electric force, and since it is moving in the magnetic field too, it will also experience a magnetic force. So the net force acting on the charged particle is given by the electric force plus magnetic force. We have to always remember that it is in the vector form, so it should be written in the vector form. And you know that electric force acting on the charged particle is given by q times the electric field, plus magnetic force is given by q times the v cross b, where v is the velocity of the charged particle and b is the magnetic field. So it could be written as q into E into unit vector, E is along j, so it will be j cap, plus q into v, and v is along I, so v I cap cross b k cap. So it will be equals to q e j cap, and here q v and b, it will be q v b, and I cross k, it is minus j minus j has been taken, minus sign is here, so it will be equals to qe minus qvb j cap f. So we will take one special condition, and the special condition is that let us suppose that let f is equal to 0. Now since f is equal to 0, then this term should also be equal to 0. Since j cannot be 0, then the quantity in the bracket should be equal to 0. If this is 0, qe minus qvb equals to 0. So we can write that qq you will lose, so we will get velocity v equals to E by b. So this is the velocity of the particle, v equals to E by b. If a charged particle is having the velocity equal to E upon b, if velocity is equal to E upon b, then in that case force will be equals to 0. So this is a very important condition. So if a charged particle is moving with the velocity E upon b, then the net force acting on the charged particle will be 0. And if the net force is acting is 0, then according to Newton's first law, body at rest will remain at rest, and a body in motion will continue to be in the state of motion along the same straight line. Yes. So this charged particle which is moving along x-axis, if its velocity v is equals to E upon b, then it will move in the same direction, that is x direction. Its direction will not change. So this is the use of velocity selector. So with this we can select the charged particle of a particular. Suppose that we want the velocity of v, then we can adjust the value of E. If you increase the value of v, you will get the higher velocity. If you decrease the value of E, then you will get the lower velocity. Or you increase the value of b, then you will get the lower velocity, or if you decrease the value of b, then you will get the higher velocity. So in this way you can get the particular velocity. So that's why it is called the velocity selector. So here some of the points that you have to keep in mind, that in order to get the velocity selector, the three things must be perpendicular, and that is your velocity vector, electric field vector, as well as magnetic field vector. Is it clear? So in this way you will get a particular velocity v equals to E by B, which the particle will having this velocity will remain undeflected, whereas if the particle is having more than this or less than this E by B, then they will either deflect in plus y or in minus y direction. Yes, so this is the very important use, and it is used in the enrichment of the particle for particular velocity. Thank you. This is all about the